What's up, science nerds? You're here watching a video on how to balance equations, right? So clearly you must be a science nerd. That's okay, because so am I. Last video that I posted was on how to take inventory. And in this video, we're going to show you how to finish this idea of balancing an equation. Don't be offended that I called you a science nerd, okay? Some of you are right now. Just don't be offended by it. On the board, we have the equation that we ended with in the last video. Let me get you brought up to speed in case you didn't watch that last video and you're just watching how to balance equations. This chemical equation on the board, we took inventory by drawing a line, separating our reactants from our products. And then we just figured out how many aluminums we have and how many oxygens on this side of the equation. To compare it to the other side of the equation, how many aluminums we have and how many oxygens we have. And we determined it's not balanced. Right? We need it to be balanced. So here's the game of balancing. The good news is we don't have to mess with the equation at all. We don't have to break apart anything or write any new elements up there. The only thing we have the power to do is to write coefficients in front of these different small mini formulas in the whole chemical equation. So for example, we could place a coefficient right there, and we're talking about positive whole numbers. Okay? We also could place a coefficient right here, and we could place a coefficient right there. We have no business writing numbers down as like subscript to the lower right. We can't put any there, right? This is a finished chemical equation. We just need to make sure that it's balanced. So the more of these you do, some patterns will start to pop out. For example, when I look at this equation, one of the things I notice is this relationship of oxygen on the left side to oxygen on the right. I've got 3 oxygens here, and I've got 2 oxygen over here. A 2 can never be a 3, and a 3 can never be a 2, right? So why would they even try? But the first number that they'll both go into evenly is 6. So that's my magic number. This is a pattern that pops out to me because I've done these over and over and over again. All right? So what number do I have to put here? What coefficient that I multiply by 2 that will get me to 6 oxygen? That's my magic number. In this case, it's going to be a 3. Now, in the last video, I said you got to be good at taking inventory because every time you put a coefficient in there, you have to update your inventory. This number 3 only applies to this part of the equation, so in my inventory down here, I'll just keep updating oxygen. I like to keep that 2 there and cross it out just so I have a record of what it once was. 3 times 2 gives me a total of 6 oxygen. Okay? Now come over to this side. Oxygen is tied up with the aluminum, so I have no choice but to put a coefficient here that applies to this whole part of the equation. So if I have 3 oxygens, I'm going to multiply by 2. That's my coefficient. The 2 multiplies to the 3 and gives me a total of not 3 oxygen, but 6 oxygen. Okay? That's great because we just balanced the oxygen. But this 2 also applies to the aluminum. I started off with 2 aluminum, so 2 times 2 bumps my aluminum from 2 up to 4. So my work isn't done yet because I have 4 aluminums now, and I still only have 1 on this other side. Now, why did I start with the oxygen? I saw aluminum here all by itself. It's not tied up or bonded with anything, and that's fantastic news because at the end of this process, I can put any coefficient in that I want. Let's see if I can do it right there. And as I put a number there, it only applies to aluminum. That's it. It's an easy cleanup at the very end. So if I need 4 aluminum on that side, I can simply just put a 4 here, change my inventory from 1 to 4, and now everything is balanced. 4 aluminums on this side, 4 on that side, 6 oxygens here, and 6 oxygens there. And because I didn't alter the equation that we started off with in any way, I just added those coefficients, my answer will be 2, 4, and 3. Those coefficients that I used to balance the equation in that specific order shows that I've now kept the law of conservation of mass in good standing, and it is now a balanced chemical equation. All right? If that was all you needed, go ahead and stop this video. You're done. I'm going to show the example that I started off the last video with. We'll take that one from start to finish, so if you want to stick around, we'll do one more. In the last video, we started off with boron and fluorine, and so if you kind of want that one to be complete in your mind, here's how it started off. We started off with boron all by itself, and fluorine, I believe, with just 2. and then that formed boron with fluorine. Oops, sorry, this is a 3. Like so. I'm going to take inventory real time, real speed. In case you saw it last time, you don't need to see it again, so we'll go kind of quick here, but I won't skip any steps. Draw the line. I have boron and fluorine on both sides of the equation. Remember, the inventory down here doesn't affect the equation in any way. I have 1 boron, I have 2 fluorine. On this side, 1 and 3. So I've taken my inventory and I know that this is unbalanced. Fluorine is unbalanced, but notice how, sorry, I'm looking for the green, looking for this right here. Notice how we have that same relationship, that 2 to 3 relationship like we did in the last equation, right? So what's the first number that 2 and 3 can both go into evenly? And that's 6. So we need to somehow get this fluorine from 2 to 6 and get this fluorine from 3 to 6. So the only place we can add coefficients, remember, are in these spaces right in front. Let me make that a little darker. Right in front of these different parts of the chemical equation. Each individual little formula has an area for a coefficient, but I can't mess with the equation in any other way, right? So we'll focus on our fluorine because it's the only thing that's unbalanced right now. If I need 6 fluorine, why 6? Because that's the first number that 2 and 3 will go into evenly. I'm going to put a 3 here. 3 times 2 gives me 6 fluorine. Okay? Let's go to the other side. You're probably already starting to notice, because you've done a bunch of these, I'm going to mess up boron in the process, but that's okay. Focus on fluorine. If I have 3 fluorine, I can put a 2 here, and that 2 times 3 gives me a total of 6 fluorine. That's good. They're balanced. Now you're right, this 2 does affect the boron as well. So I don't have 1 boron over here. I have 2 times 1. I have 2 total boron. So remember, the coefficient applies throughout the whole portion of the formula. The little numbers down here, the subscripts, only apply to the element that they're right next to. Okay? So what's the good news? Boron's sitting over here all by itself. A coefficient that I put here doesn't affect anything but that 1 boron right there. So if I have 2 over here, 2 borons, and I need to bump this one up to 2, I can do that by putting a 2 here, and it will only affect that boron. Remember, a coefficient does not apply across a plus sign. A coefficient does not apply across our arrow, our yield. It only applies to that section of the formula that it's right next to. All right? So with that, please come with specific questions, concerns. Bring your assignments in before school, after school seminar, and we'll get you squared away.